Hello, hello, chemistry. All right, a couple of you have asked me for a video on covalent bonding, or covalent naming. So I'm gonna make this one real quick. I'll go through 3 or 4 of each of these, and I'll reiterate the prefixes and the rules. But this is basically just going to say what I already wrote out. So we'll go ahead and go through this. Shouldn't take too long. And then the next video is ionic naming, the first part. So these 4 pieces of information are your naming rules. So whenever you're turning a formula into a name, you have to add a prefix to each element in order to state how many there are. So we're going to start off by giving the prefixes. Now I'm giving you 12 prefixes for 1 through 12. And this prefix states how many of an element there is present. So for example, you guys have all heard of carbon monoxide. Mon or mono means 1, means that there's 1 oxygen, 1 oxide. So that's all these prefixes really mean. So 1 is mono, 2 is di, 3 is tri, then tetra, and from here, they're the same as your polygons in geometry. So penta, hexa, hepta, octa, nona, deca, undeca, and dodeca. And these are the prefixes that I gave you in the original announcement. So if you weren't 100% sure what to do with those, this is what you do with those. They're just the prefixes that you need in order to do this naming. So, looking at our first one, we have 1 carbon and 1 oxygen. So according to this, we would say the prefix that states how many there are, so mono for both, so monocarbon, monooxygen. Okay? But there are a couple other rules here that we need to go through. So if there's only one of the first element, we don't put a prefix. This is why carbon monoxide or carbon dioxide is carbon. It's not called monocarbon dioxide. It's just carbon dioxide. Because there's only one of the first element, so we don't state it. Kind of like we don't put ones as subscripts. So it would not be monocarbon monooxygen. It would be just carbon monooxygen. Second element must be named as an anion, which means that it has to end in IDE. So instead of oxygen, it's oxide. So carbon monoxide or monooxide. And then the last one, when a prefix ends in a vowel, which all of them do, and the element begins with 1. So this is mainly going to come into effect for oxygen, because I think oxygen and iodine are the only 2 nonmetals that you're going to be working with that actually start with a vowel. So whenever you have oxygen or iodine, you're going to have to keep this last one in mind. You omit the vowel from the prefix. So it's not heptaoxide, it's heptoxide. We drop the A off the end of the vowel off the end of the prefix. So here, for carbon monoxide, we'd write out carbon monoxide. Instead of monooxide, it's just monoxide. Now, we do not do this with di or tri because those prefixes are extremely short. And so losing that vowel can significantly change the word or the prefix itself. So dioxide and trioxide will still have that I sound in it. So this is obviously water, but water is the common name. This is the actual covalent name. So we have 2 hydrogens and 1 oxygen. So dihydrogen monoxide, or dihydrogen monoxide. Carbon, there's just 1, so we omit the prefix. Forgot the R there. Carbon. Sorry, I had to pause that so I could sneeze. Carbon, and we have 4 hydrogens, so the prefix that means 4 is tetra. So tetrahydride. Because it has to end in IDE for the second element. So then this would be dinitrogen monoxide. And the last one that I'm going to do with you is N2O3, which would be dinitrogen, again. 3 is trioxide. Okay, and that's really all there is to the naming. Covalent naming is very, very easy. We just have to state the prefixes so that we know how many there are because of that sharing of electrons. Because of how that works, we have to actually state how many of each element is present. Now, when we start pulling formulae out of the names, we use the same information. We're just going in the opposite direction. It's actually even easier. So carbon, and since it's just carbon, there's no prefix, we know that it has to be just 1. Dioxide, so 2 oxygen. Nitrogen, trihydride, so 3 hydrogen. Nitrogen monoxide, so NO. Dinitrogen pentoxide, so N2 is di. Pentoxide would be O5. And the last one would be phosphorus trichloride, so again, just 1. P trichloride Cl3. That's really all there is to covalent naming. It's very, very simple. So I hope this helps for those of you who actually watch it. For those of you who don't watch this, obviously, you're not going to know how easy this is, I guess. So finish this up. Work through the worksheet that I posted. It is broken into 2 documents. It's got this and this in a Google form, because this you can do in a Google form. This, you have to actually write out the formulae on a sheet of paper, and then you'll actually upload pictures of that into the worksheet, the Google Doc, just like we did for the structures drawings earlier. This worksheet is not for a grade, but it is the practice for the quiz, which is, I believe, on Wednesday. Not 100% sure on that date, but I think it's on Wednesday. So that's all for this video. Have a wonderful night, and I will see you all at some point, I guess. Hopefully this helps. Bye.